Hello, here is the presentation from Group 1A and we are responsible for the question 1.1 to 1.10. Our group members' names are on the list with their ID number. Okay, let us start now. I'm Cheng Lam Cecilia, and I will be doing question 1.1 and 1.2. In question 1.1, we need to find the mean first. The formula of the mean is to add up all the money in the balance column and divide it by the number of the account, which is 150. For each of the balance, we need to find the midpoint since it's a grouped data. One example is 0 plus 100 and divided by 2. Then it would become 50 times 36 and do the same things on each of the balance, so the equation of this will appear. The answer is 261 pounds. Then we need to find the mode. The formula of the mode is shown here. L is the lower boundary of the model class, H is the size of the model class, Fm is the frequency corresponding to model class, while F1 is the frequency preceding to model class, and F2 is the frequency proceeding to model class. Then we need to make the substitution and we will find this equation. The answer would be 135.7143 pounds correct to 4 decimal places. The last one will be finding the standard deviation. In this question, the formula of sample standard deviation is used. X equal to each of the value of the data, X bar equal to the mean of the data, and N equal to the number of data points. After inputting all the data into this formula, we will find this equation, and the answer is 211.7259 pounds, correct to 4 decimal places. Then we will go to the next question, question 1.2. For question A, we need to find the mean first. The skill and the formula is same with question 1.1. The equation is shown, and the answer is 50 over 7 minutes. As for the median, the formula is shown here. L1 is the lower boundary and L2 is the upper boundary. N is the total frequency, C is the cumulative frequency before the medium class, Fm is the frequency of the medium class. After inputting the number into the equation, this one will appear. The answer is 51 over 7 minutes. For question B, we need to find the range and the standard deviation. For the range, the formula will be the largest boundary minus the smallest boundary, which is 40 minus 2, and the answer is 12 minutes. The last part will be finding the standard deviation. The formula is same with question 1.1, and we need to substitute the number into the formula with the mean that we have calculated in question 1.2a. Then the equation is shown. The answer is 2.5959 minutes, correct to 4 decimal places. Okay, this is the end of question 1.2 and 1.1. Thank you.
I'm Chan Pui-tong, and I'm going to talk about question 1.3. So the question requires us to determine the population mean, the median, and standard deviation of the values in the following 20 data. So let's talk about the population mean first. Population means is the mean of all the values in the population. So we need to sum up all the data and then divide it by the number of data, which is 20. So the answer would be 9.929. And then for median is the middle number of the data set. So we divide the number of data and then divide by 2, and we'll find that is 10. But 10 is an even amount of number. So it means that it is not a middle number, but actually a middle pair of number. So we need to add up the 10th and the 11th data and divide by 2, and which is 9.53. And then in the end, to calculate standard deviation is a measure of how dispersed the data is in relation to the mean. So it explained why we need to add up all the data minus mean and square it and divide by the numbers of data and then square root it. So after calculation, like the data minus the mean 9.929 square and add up all the thing divided by the data of the number of data, which is 20, and we get the answer 2.810. And that's the end of question 1.3. Thank you.
Hi, my name is Eunice. Today I will be talking about question 1.4. So here's a sample of 50 antique dealers in the Central District. Revealed the following sales last year. So as we can see, there are 6 different classes, and in different classes we'll be finding the midpoint and the CF of each class. So first of all, in part A, we'll be finding the mean sales and the median sales. So from the mean sales, we will be calculating it by this formula, and then we can get the answer by 161.2. And then for the median, since we can see there are 50 different kinds of firms, so the 50 divided by 2 is 25. So we can see that the 25th is in the class which is 160 to under 180. So we will calculate the median by this formula, and then we can get the answer 165. So for part B, we will need to find the range and the SD. So we can see the least is 100 and the most is 220. So we will be finding the range by 220 minus 100. So we can get 120. For SD, we'll be calculating it using this formula. So at the end, we can get the answer 27.748. So now let's pass the time to Mandy. Thank you.
I am Ming Mandy. I'm going to talk about question 1.5 and 1.6. For the question 1.5, it stated the number of cars sold by each of 10 salespersons in an automobile dealership during a particular month. For A part, we need to determine the mean. Mean equals to total number of cars sold divided by the total number of salespersons. The total number of cars sold is 2 plus 4 plus 7 and so on, which equals to 96 and divided by 10, so the mean equals to 9.6. For the standard deviation is square roots of sum of x minus mu and all squared divided by n. When we're substituting the number into this formula, we will find that the standard deviation is 3.9547 correct to 4 decimal place. For the C part, we need to determine the range. The range is the largest minus the smallest. In this case, the largest is 15 and the smallest is 2. So when 15 minus 2, we will obtain the range as 13. For the D part, we need to determine the interquartile range, which is quarter 3 minus quarter 1. Since quarter 1 is the 25th percentile, and we all know that n equals to 10, so when 0.25 times 10 equals to 2.5, since it is not an integer, so we need to round it up to 3, which means quarter 1 equals to the third observation, which equals to 7. And we can use the same way to calculate quarter 3, which is 0.5 times 10 equals to 7.5. And since it is not an integer too, so we need to round up to 8. That means quarter 3 equals to the 8th observation, which is 12. So interquartile range equals to 12 minus 7, and minus 7 equals to 5. For question 1.6, it stated the weight of a sample outgoing package in mailroom weighted to the nearest ounce. The question has a sample, which means it is a sample standard deviation, and we need to arrange the number in ascending order as follows. And we find that n equals to 10. For A part, we need to determine the mean, which is the total weight of a sample outgoing package divided by the total number, which is 191 divided by 10 equals to 19.1 equals to 19. Correct to the nearest ounce. And for the B part, we need to calculate the standard deviation, which is the square root of sum of x minus x bar and all squared up divided by n minus 1 instead of n. When substituting all the number into this formula, and we find that standard deviation equals to 6.7569 equals to 7 correct to the nearest ounce. And for the C part, we need to calculate the range, which is the largest minus smallest. And in this case, it is 13 minus 10 equals to 20. For the interquartile range, it is quarter 3 minus quarter 1. And we know that n equals to 10, so when 0.25 times 10 equals to 2.5, we need to round up to 3. And we found that quarter 1 is the third observation, which is the 14. And 0.75 times 10 equals to 7.5, we need to round up to 8 and found that quarter 3 equals to 25. So interquartile range equals to 25 minus 14 equals to 11. That's the end of question 1.5 and 1.6. Thank you.
I'm Wang Tinok and I'm going to talk about question 1.7. In question 1.7, it is stated that the following are sample service time data for completing a specific task in minutes for Team A and Team B. We are asked to calculate the coefficient of variation for Team A and Team B, and also intercept the results. For a CV percentage, it is equals to standard deviation divided by the mean times 100. The mean of Team A is 13 and the mean of Team B is equals to 22.2. The standard deviation of Team A is equals to square root of sum of x minus x bar square divided by n minus 1. By substitution, the SD of Team A is equals to 3.91578041. The CV is equals to the standard deviation of Team A divided by 13, which is the mean of Team A, times 100%. The CV is equals to 30.1%, correct to 1 decimal places. And by the same equation, the SD of Team B is equals to 7.5099993342, and the CV is equals to SD of Team B divided by 22.2, which is the mean of Team B, times 100%, which is 33.8%, correct to 1 decimal places. As the CV of Team B is greater than the CV of Team A, Team B is more dispersal than Team A.
I'm Zheng Yan and I'm responsible for the question 1.8. The question asks us to calculate the person's second coefficient of skewness. So the formula of the SK2 is I've written down at here. It is 3 multiplied mean minus median and divided by the SD. So to calculate the SK2 of test 1, we will have to substitute the data provided in the question into the formula. And here is the results. And for test 1, the SK2 is 1. For test 2, also by substituting the data provided in the question, we can get this formula and the result is right here. So by comparing the two tests, we can see that test 1 is positively skewed as it is 1, and test 2 is negatively skewed and the answer is here. So as a result, test 2 shows a better result. So that's all for question 1.8. Thank you.
This is question 1.9. In this question, we need to calculate SK1 for Team A and Team B. So first, we know that the formula for SK1 is mean minus mode divided by standard deviation. For Team A, the mean is 36 plus 45 plus to 99. divided by 10 is equal to 66.6, and the mode for team A is 72. So we can calculate the SD for team A, as the following picture shows is approximately equals to 19.07. So finally, the SK1 for team A is in the picture is approximately equals to minus 0.31, is below 0. So the distribution is for team A is negatively skewed. Team B is the same. First, we calculate the mean is 16 plus 20 plus 2, 44 divided by 10 is equals to 29.2, and the mode is 28, of course. And we can calculate SD for team B, as the picture shows, is approximately equals to 8.44. And finally, SK1 for team B is approximately 0.14, is among 0. So the distribution is for team B is positively skewed.
Hello, I'm Angus. In the following, I'd like to talk about the questions Q1.10. It gave us some sample service time data collected for Team A and Team B. Then it asks us to calculate about the Pearson second coefficient of skewness and interrupt the result. And for the equation, the second coefficient of skewness is equals to 3 times the mean minus the median and divided by the standard deviation. And for the standard deviation here is a sample standard deviation, which means in the equation it is divided by n minus 1 instead of n. Alright, for the mean, it's basically the sum of all the data and divided by the number of data. For team A, we can got 26 minutes, and team B, we can got 22.2 minutes. And for the median, it's basically the 5th and the 6th data added up together and divided by 2, which we can got both are 24 minutes. And for the sample standard deviation for team A, we can get the answer is 7.8315600083, and team B is equals to 7.5099993342. Let us calculate the Pearson second coefficient of skewness. For team A, we can get the answer is 0.7661, which is correct to 4 decimal places. And for team B, it is equals to negative 0.7190, which is also correct to 4 decimal places. For team A, we can see the answer is larger than 0, and for team B is smaller than 0, which means that distributions in team A and team B are positively skewed and negatively skewed respectively, since the data is recording the computing time of a specific task, which means the faster time it is, the better performance it is. By comparing two data, we can see Team A show a better result. And that's all the presentation for questions Q1.1 to 1.10. Thank you very much.